Hello and welcome to day 12 of the 12 projects of Codemas, our last day. Let's go ahead and get right on into it. All right, our final unboxing. Alrighty, looks like we have one custom addressable LED strip with Mel jumper wires. Alright, Maker Advent Calendar day number 12, RGB LED strip. It's the final day of your 12 projects of Codemas Advent Calendar. Today we're playing with an RGB LED strip, but these aren't regular LEDs. These are addressable LEDs, meaning we can code all sorts of colors, patterns, and sequences. Time for some ultra festive blinky. Warning, some of today's activities contain flashing lights which may not be suitable for those with photosensitive epilepsy. Alright, as we saw in the unboxing, we got the one custom addressable LED strip with Mel jumper wires. Today's project. Today is a big one. We're going to learn how to light up the LEDs in our strip individually, how to code different colors and color lists, how to create a light chaser, then a light chaser speed controller using our potentiometer from day number 4, some button color control, then fading effects. Phew. Before we start, let's talk about what an addressable LED is. Addressable RGB LEDs. The LEDs in your strip are WS2812 addressable LEDs, sometimes called NeoPixels, which is a branded version from our good friends over at Adafruit. These are a special kind of LED that actually contain 3 small LEDs inside each, one red, one green, and one blue, which we mix to create lots of different colors with our code. This is why it's an RGB strip, our red, green, blue. We'll talk more about that in a moment. Each of these LEDs has a tiny microcontroller chip that inside that allows us to address or talk to them individually in our code, unlike more traditional lighting options which light the entire strip in a single color. However, because of this, they always need a microcontroller to tell them what to do. With much longer strips, you would usually have to worry about external power, resistors, and other technicalities. However, the compact custom strip in your box is short enough to allow us to avoid all of these distractions. We will be powering it from a different pin this time though, the V-bus pin, or physical pin 40, as this will provide the full 5 volts the strip needs rather than the 3.3 volts pin that we've used so far. We've also had this LED strip made especially for this calendar with handy jumper wires so you don't need to mess around with connectors and tools. Step 1, construct the circuit. Disconnect your Pico from the USB board on your PC so it's safe to amend our circuit. We're starting with a mostly bare breadboard, so remove any other parts that may still be in place from yesterday. Alright, now grab your LED strip and fit the 3 wires as follows. Place the red wire into the V-bus pin or physical pin 40, not the 3v3 pin this time. Fit the black wire into the ground pin, which is physical pin 38, and fit the green wire to GPIO 26 or physical pin 34. Next, we add one of our buttons and the potentiometer. Fit them to the left of the Pico as shown below. Remember that your potentiometer will have a gap between each of the legs, unlike our diagram. Let's wire the button next. Our button will need the usual 3.3 volts, not the 5 volt on the V-bus pin we're using for the LED strip. Connect the left leg of the button to the upper red channel. Connect the right leg to GPIO 15 or physical pin 20, and then use another wire to connect the 3.3 volt pin to the upper red channel. Finally, we connect the potentiometer with 3 wires as follows. Connect the left leg to the ground pin on physical pin 18, connect the middle leg to GPIO 26 or physical pin 31, and connect the right leg to the upper red channel. Activity 1, minimal starter program, 1 LED. Time to twinkle. Plug your Pihut back into the USB port on your computer and we'll get this thing all lit up. Now while we could just straight into something flashy and colorful with all the bells and whistles, we want to guide you through some easy examples first so you can understand how the code works. This minimal example lights the first LED in red just to get to grips with how the library works, which is now included within MicroPython, so we don't need to install anything. These strips can show lots of different colors as they are RGB strips, so let's cover that first. What is RGB? RGB stands for red, green, blue. It's a color system used in computing to display colors on a computer display. The 3 colors can be combined to show a huge range of different colors. With RGB, each of the 3 colors can be set to an intensity value between 0 and 255. As each of the 3 colors has 255 possible different intensity values, technically there are 16777,216 possible color combinations, although your eyes probably won't notice the difference between a lot of these when they're used with LEDs. RGB with LEDs. How does this relate to our LED strip? Well, as we mentioned earlier, inside of each of these clever LEDs are 3 smaller LEDs. 1 red, 1 green, and 1 blue. We send code to the strip to set the RGB intensity value for each LED, allowing it to mix and show different colors. There are lots of online tools to help you find the RGB values for your desired color, such as this handy page from Rapid Tables. For example, basic red is 25500. The code. Our example code imports NeoPixel, which is the name of the library now included in MicroPython to drive these kinds of addressable LEDs. To set the LED strip up, line 7 sets the pin number for the strip, GPIO 28, and the number of LEDs on the strip, which is 15. We can now refer to it using strip in our code. To send data to the LED strip, we first write that we want to do it. We first write what we want it to do, then use strip.write to send it to the strip, a bit like how our OLED display worked yesterday. In the example below, we use strip 0 equals 25500. The 0 is telling our strip to drive the first LED only, because the first LED starts at 0 and the second is 1 and so on. The numbers in the brackets are for the RGB value. We're using 25500, which is red at the brightest intensity. Copy the code below over to Thani, run the code, and then try the following tasks to get the hang of things. Alright, and we see the first one goes red. Try changing the 255 to 10. What happens? Yep, we see it went super dim. Try changing the RGB value to 010. Alright, so we see it went green. Now try changing the 0 to 7. Alright, let me see, now this one's lit up. Alright. Activity 2, using multiple LEDs. Our next step is to drive more LEDs in our strip. We'll first show you a basic method of doing this, then a more efficient method, and then a much better method, which will keep your code nice and compact. To light more of our LEDs, we need to tell MicroPython which LEDs we want to send data to. So far, we've only told MicroPython to light up LED 0, or the first LED, and 7. A basic method. A basic way to do this is to just add more lines, changing 0 to whatever number of LED we want to light up. The example below does exactly this, which will light up the first 5 LEDs in red on your strip. Give it a try, then keep adding additional lines until you have a line for each of the 15 LEDs. All right. A better method. Let's improve our code to save the number of lines we're using while making things a bit clearer. The only thing our code is changing is the pin number for each of the 15 LEDs, so we can make use of a for loop and the range function that we've used previously. We use a for loop to iterate over each LED in our strip. We know that we have 15 LEDs, so we can use for I in range 15 to tell this code block to iterate over a range of 15. This range using I is injected into our LED strip line as we use strip I equals 25500. It does this for the entire range of 15 LEDs. Then once the for loop has completed, the final line writes this data to the strip, which makes them all light up. This still isn't the best way to simply fill the entire strip, but this example will be useful later on as we want to run when we want to use some effects. So it's a good one to give a try. All right. An even better method. Want to simply light the entire strip without any flexibility? It's super simple. Just use strip.fill, and it'll light as many LEDs as you have defined in the setup line, which is line 15 for us. Make sure you use 2 sets of brackets with this one. Try the simple example below. Splash of turquoise, anyone? Then have it play around with the RGB color codes. Better color management. We now know how to light multiple LEDs, and we know how to create RGB colors. Let's show you a few tricks to help you manage colors a little easier. Then we can move on to some really fun stuff. Your program currently uses the RGB values set to set a color, but when you're looking back and reviewing your code, it can be difficult to remember what they are. A better way is to create color variables with the color's name. We've used variables a lot over the last 12 days, so you might already know what to do here, but we're going to show you just in case. We're going to take the example above, activity 2, and add variables for 5 different colors. We can then use these colors in our LED strip code to easily change the color by just using the color's name, such as strip I equals red. Give the code below a try, and then try changing the color name in the brackets to 1 from our variables. Color lists. Now that we have our color variables set up, we can also set a list of these colors, which we can use later in a for loop to iterate over, allowing us to work through a selection of colors in our code. But what are lists in MicroPython? Lists. Lists are another handy tool for your MicroPython toolbox. They are essentially a variable with multiple items inside. The items can be any data type, strings, integers, variables, etc. Let's run a quick example, then we'll use list in the next activity. The short example below creates a list called myList and includes 4 strings inside square brackets separated by commas. That's it. Lists are as simple as that. In our example, we then print this list by using the list name variable in the print line. Pop this into Thunny and give it a try. All right. Activity 4, light chaser. Let's step it up a gear and create something really cool, a light chaser. How very festive. In our example below, we've created a list of color variables called colors. We have also placed our LED code in an endless while loop, which contains a for loop with a nested for loop inside it. Why use a nested for loop? A nested for loop allows us to iterate over the colors first, then iterate over the LEDs. The code is saying for every color in the colors list, run my code block. And that code block then includes another for loop that runs this color through our range of 15 LEDs. Once the range has run out, it jumps back to the initial for loop for the next color and does it all over again. We use J for colors and I for the LED range. Remember from the previous boxes, it doesn't matter what we use here. We could use color instead of J and LED instead of I. There are no rules here, just traditions. When to write data. Another key change is when we write the data to the strip. Earlier, the strip.write was outside of and after the for loop, waiting for the loop to finish setting all of the 15 LEDs before writing data. This time we write the data with the for loop after each iteration, after each single LED is set. This means the for loop finds the next LED in the range and lights it up before moving on to the next LED, which gives a chasing effect to the LED strip rather than writing all 15 at the same time. We also use a simple time delay before writing the LED to set the speed for the chaser. That's a lot to take in, so try the code below and reread the above while watching it dazzle. We'd also encourage you to add more colors and play with the time delay. All right, so let's go ahead and run it first. Okay. So for J in color, so for each of these colors in this list, and for I in range 15, so for each of the 15 LEDs, set each LED in the range to red. Delay, and then send the data to the strip. Okay, so to red, but that should just say color, basically. For every color in the colors list, run my code block. And that code block then includes another for loop which runs this color through our range of 15 LEDs. Once the range has run out, it jumps back to the initial for loop. All right, simple enough. Activity 5, speed controlled light chaser. We're now going to reintroduce our potentiometer to our code to allow us to control the speed of the light chaser. We will use the potentiometer ADC reading and use this to drive a variable for the time delay, just like we did in box 4 to control the speed of the flashing LEDs. The code. We don't have to change our original light chaser code much to achieve this. We simply add ADC to our imports, set up the GPIO pin for the potentiometer, add a line of code within the nested for loop to read the potentiometer into a variable, then divide that number to make it more useful as a time delay. Use that reading variable to drive our time delay. If we didn't divide the sensor reading, we would be sending values from 0 to 6, 55, 35 to our time delay as seconds, which would be far too slow for the effect we're looking for. Copy this over to Thani and give it a go. As you turn the potentiometer left, it should reduce the time delay and make the lights chased faster. You can change this number. You can change the number we divide the reading by to increase or decrease the minimum delay, or perhaps add some of your favorite colors as variables. All right. Alrighty, activity 6, button color control. We're going to hop back to the strip.fill to completely fill our LED strip with a single color. However, this time we're going to use our button to change the color of the strip. This sounds simple, but we need to change our approach to make it work. Instead of entering the color directly into the code using something like strip.fill red, or using a for loop to automatically iterate through our list of colors in order, we're going to use another method which uses the index of each color in our color list. But what is an index? Each item in a list is given an index. This means that each item in a list is given a number starting from 0. Let's take our current list, which is red, green, blue. The index for this list would be 0, 1, and 2. 0 equals red, 1 equals green, and 2 equals blue. We can use this to pick a specific color from our list by changing how we use the strip.fill line. For example, strip.fill colors 1 will use index 1 from the colors list, which is green. You're probably thinking, but we could use strip.fill green. We could just use the strip.fill green. This is true, however, as the index uses a number, it allows us to easily change that number and therefore the color with our button using variables. Our code also needs to know the length of our index, how many colors we have in our list, so that our code doesn't try to use an index number that's outside of our list range. For this, we used len. Wait, who is len? No, not len, len. We use len to return the number of items in a list. We simply use len followed by the name of the list in brackets. If our list looks like this, colors equals red, green, blue, then we would use len in the following way to count and print how many items are in our list, which would be 3. Print len colors. Try the following quick example to see this in action. All right, so 3. The code. This is where everything above should come together and make more sense, we hope. Our code example below has some new variables. My index, we use this as an index number to select a color from our list. We change this number when the button is pressed to move it to the next number in the index. The next color. Index length. This counts the number of items in our list, 3 in our example. However, as we're using this to identify the last number in our index, we have to -1 at the end because there are 3 items in our list, but these will be indexed at 0, 1, and 2. We want our maximum index value to be 2. The example code below uses a while loop that does nothing, just a delay, until a button is pressed. Once the button is pressed, it uses an if statement to check what the current myIndex variable value is. If the myIndex variable is less than the index length variable, if myIndex is less than 2, it will add +1 to the myIndex variable. We also use an else statement under this to catch when myIndex is 3, which resets myIndex back to 0. Regardless of whether the if statement or else statement has triggered, both will alter the myIndex variable, then move to the code below them. These final lines of code update the strip.fill with the index number using the myIndex variable, and then writes the data to the LED strip. We only write the data to the LED strip here, as this means data is only written when there is a change. If the button isn't pressed, nothing happens. Have a good look through the code below, then copy it over to Thani to try it for yourself. All right, let's run it and then we'll look at it. All right, there we go. Green. Button's a little loose. All right, setting everything up, define the color list, create an index variable starting at 0. Get the length of the list of colors. The initial delay. Okay, so if the button is pressed and if the index is less than the index length of the list, so that we don't accidentally go outside of that range, myIndex equals myIndex +1 to go to the next color. If it's over the index length, then we want to reset it back to 0. And then we're filling the strip with the color of the index, so it starts with 0, which will be red, and then goes through the list, and then when it hits index 3, which is outside of the list, it resets it back to 0. Alrighty. Activity 7, fading. Now let's try fading our LED strip in and out. It's surprisingly easy with some simple for loop code, and it gives us a chance to show you another way to use the range function. Our example below uses a while loop with 2 for loops inside it, both using the range function. These for loops iterate the red R value from RGB used in the strip.fill line below them, so that each iteration changes the R value. You can see where we use I instead of a value in strip.fill I00. Additional range parameters. You'll also notice that the range brackets contain 3 numbers, whereas previously we've just specified a single number to iterate over. Using 3 values or parameters lets you specify the start, the end, and the step for each iteration. Our example below uses for I in range 0, 255, 1, which is setting the start of the range to 0, the end of the range at 255, and telling the code to increase by 1 step each iteration. What does this change? What this does is change our red value by 1 step for every iteration, starting at 1 and ending at 255. This creates a fading effect as the intensity moves from 1 or dim to 255 or bright very quickly, using the delay we have set. The next for loop does the same thing but in reverse. Yes, you can go backwards with the range function. So we set our range function to start at 255 instead of 1 and to end at 1 instead of 255. The step -1 so that we continually take 1 away from that starting 255 value. Try the code below, then try playing with the color values. Try using I in the other places such as strip.fill, or add fixed values to the other colors. All right. All right. So running forever, we go from 1 to 255 here, and then we go from 255 to 1 here, and then we just continue that cycle. Fill the strip using the iterated R value. All right, day 12 complete. This is a little longer than some of our other days, as these LED strips are such a fun and versatile part to play with, and there's so much more you can do. We're pretty sure most of you will be turning your strip into a fancy monitor backlight. Perhaps some will combine it with the PIR to turn it on when there's motion in front of their PC, or some cleverly hidden brake beam sensors will be used as a hand-activated color changer. Whatever you make, we'd love to hear about your projects in the comment section. So what did we cover on day 12? Today you have learned what an addressable LED is and why they're so fun, built a circuit with addressable LEDs, learned about RGB and how to create colors with RGB values and where to find them, learned how to code addressable LEDs with MicroPython, learned different ways to light the entire strip, some more efficient than others, created color variables, learned how to create and use list in MicroPython, including list indexes, used nested for loops, learned how to use len in MicroPython, and faded addressable LEDs using range, both counting up and down. Over to you. That's it, folks. It's the end of the Maker Advent Calendar. We know many of you wanted this to last the traditional full 25 days. However, the world is a funny old place right now, and we wanted this to be as affordable and accessible to as many people as possible. We really hope you've enjoyed following along each day, and we really hope you'll continue your journey as a maker, using your selection of components to make fun projects, experimenting with different parts together to make awesome projects. We've only just scratched the surface on what's possible with this fantastic little microcontroller and the components you've discovered over the last 12 days. There's so much more to learn and experience. If you would like to expand your selection of components for the Pico, the store is full of goodies. Be sure to check out our dedicated Raspberry Pi section, Pico Section 2. More resources. The internet is jam-packed full of projects and examples using the Raspberry Pi Pico and MicroPython, and 99.9% of this information is free, so don't stop now. We've even had some great examples from makers in the comment sections of the calendar along the way. Search engines are your best friend when it comes to making and coding. Forums, blogs, tutorials, social network, user groups, and more are at your fingertips and hold an endless amount of examples, code snippets, previous discussions, and useful info. A good starting place for inspiration and a great community is in the Raspberry Pi forum, specifically the Pico section. Just don't forget to always search before asking a question. That's all, folks. Have a wonderful festive period and a happy new year from everyone at the Pihut. As always, thanks for stopping by. I hope you all had as much fun as I did. And yeah, come back soon for possibly day 13, where we'll maybe make something with all that we have from the boxes so far. So, yep. Have a happy new year.